Hi, welcome to our math. Today I'm doing a series of videos on exponential equations and specifically solving them. I have 4 equations here, so let's jump into it right away. The exponent is only attached to the 1/2. So I have to start by dividing by this 2500 because before I do anything else I need to get the exponent component alone. Because this is a decimal, I'm going to change my 1/2 into a decimal and say 0.5 to the 4 minus x equals 0.125. Okay, then I'm going to write this logarithmically. And when I write it logarithmically, what I'm going to say is 4 minus x equals, so logs are exponents, so exponent equals log. Exponents are logs, so the exponent equals a log. The base of the log is the same as the base of the exponential, and then the argument is that last number left over. A log literally answers the question, 0.5 to what exponent is 0.125. To throw this into a calculator, however, because most people don't have this change of base button on their calculator, what I'm going to have is 4 minus x equals log of 0.125 divided by log of 0.5. Log of argument over log of base. When I do that in my calculator, I'm going to get 3. I'm going to subtract 4 from both sides, so negative x is equal to negative 1, or x is equal to 1. Not sure why I didn't leave myself more space for that problem. This one is a little bit simpler. I'm going to divide by that negative 15, so that e to the 7x is equal to 3. The inverse of e is natural log. There's a button on your calculator that says ln. That's not in, it's ln, log natural. That's the inverse of e. So if I take the natural log of both sides of this equation, natural log and e are inverses, which means they undo each other, and I'm left with 7x equals the natural log of 3, which is 1.0986. I'm going to divide by 7. I'm going to get that x is equal to 0.1569. I want to round to 3 decimal places, so that 69 is going to round it up to a 7. And I have my second answer. All right, so now on to the 2 longer problems. For these, don't get tripped up by the fact that we have these 2 terms that have the 5 to the x. Just think of it as 25x equals 15,625 plus 20x. If that was the case, the first thing you would do is subtract 20x from both sides. So the first thing I'm going to do is subtract 20 times 5 to the x from both sides. I'm going to end up with 5 times 5 to the x is equal to 15,625. If this was 5x equals 15,625, you would say, oh, 5x equals divide by 5. That is exactly my next step. So that I have 5 to the x is equal to 3125. Now, you can't divide by 5 again. That's probably the biggest mistake I see students doing. The thing is, if you divide by 5, you'd actually have 5 to the x minus 1. That's not getting you anywhere. So up here, what I did was I rewrote it logarithmically. I'm going to show you another approach where instead of rewriting it logarithmically, I'm going to take the log of both sides. I'm going to take the log of 5 to the x. I'm going to take the log of 3125. The thing is, as long as you do the same thing to both sides of the equation, you maintain a balanced equation. Logs are exponents, which means the power rule says this x can come out front. X times log to the 5 equals log to the 3125, and then I can divide by log 5. When I do that, this I can throw into a calculator, and I get that x is equal to 5. No rounding needed. All right, for our next problem, it looks pretty identical with a few extra terms. These are like terms because they both have the m, and there's an implied 1 here. So if I subtract 1.25 to the m from both sides, and I add the 777, these combine to be negative 14 times 1.25 to the m, and these combine to be a negative 100,648. Okay, now I'm going to divide by that negative 14. So I have 1.25 to the m equals 142.857. Now here's the deal. I often leave these as fractions. I went to decimal this time. As long as you go out enough decimal places, knowing that you're rounding to 3 decimal places, it should all work out just fine. I'm going to take the log of both sides again, so I'm going to take a log of the left, log of the right. The power rule says m times log of 1.25 equals log of 7,189.142857. Divide by log of 1.25. And I get that m is equal to 39.7964. Rounding to 3 decimal places, the 4 leaves the 6 as a 6, so m is going to equal 39.796. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!